Welcome back, guys. In this presentation, we're going to talk about the concept of VLANs and then go ahead to configure the access port and trunk port on Huawei's Enterprise Network Simulation Platform, the NSP. So to start with, this is the topology we're going to use for this description. We have here two switches which are connected directly together using a trunk link, and then we also have some computers as well connected to these switches. So before we do this configuration, let's look at the basics, why we need the VLANs in the first place. So for this, we're going to look at this topology. This basically consists of multiple computers connected to each other via a network of switches. So all the S5700 devices are switches which are interconnected together. Now in this case, we have end stations or endpoints like the PCs and servers. Yeah, the endpoints could be the IP phones or IP cameras in this kind of scenario, or even printers on the network. So what we want to do in this case is to examine how the traffic is forwarded. So let's take a simple scenario. So we know for a fact that the switches maintain a MAC address table which consists of a mapping between the MAC addresses of the devices and the port on the switch in which they are connected. But before the switches learn the MAC addresses, the MAC address tables are empty, so there is no way the switches know what devices are connected, except of course they learn through data frames that are sent by the devices or through the ARP mechanism. Now, we're looking at a simple scenario where the source device, which is this PC in this case, is sending a unicast packet to the destination PC. However, we're also going to make another assumption that the network is a flat network, meaning that all the ports are belong to the same broadcast domain, and devices can receive broadcast traffic sent from a single source. So what we see here is, even though we make the assumption that the switch 18, switch 4, and switch 6 have the mapping for the destination PC, we cannot guarantee that a broadcast or unicast traffic will not get to other devices. So one of the first things we see is if all the devices here, for example, have no knowledge of the destination PC's location, so it means that any traffic sent by the source PC will be flooded across the entire network and received by end stations that may not require this traffic. So one of the disadvantages we have with a large broadcast domain is the lack of security across the network and terminals. So we already described this by giving the simple scenario where the source PC sends a unicast or broadcast traffic on the network. So this will be delivered to all other terminals, irrespective of the actual destination PC. So the second thing we're going to look at is the bandwidth utilization. So if these broadcast traffic keep getting flooded on the network, or unicast traffic keep getting flooded, we come to a scenario where the available bandwidth on the network is reduced because of the huge amount of junk traffic that is forwarded on the network. And the third scenario, the third problem we have is we cannot flexibly define policies, meaning that you can have IP phones connected to the network, IP cameras, you can have printers, you can also have PCs and servers connected, but if they all belong to the same broadcast domain, then you cannot flexibly define policies for only IP phones or a group of policies for all the IP cameras. So it means that you can only define policies for the entire network, which is not very efficient. So one of the very weird scenarios that we need to consider is, we know for a fact that a router will isolate broadcast domain. So what that means is whatever broadcast traffic, for example, is sent by PC7 will never cross the interface gigabit Ethernet 002 on the router. So the routers will isolate the broadcast by default. We may see this as a temporary solution, but it poses much of a problem. One of the problems is, the routers generally have very few interfaces you can connect to, and to connect more terminals, so when the network expands, it means you have to buy more routers, and this is going to be quite expensive. So one part is this is going to be expensive to set up and manage. And the second is we also need to consider that having a network change is not very flexible in this scenario. And the third one is the configuration is very complex. If you've done more than one setup for a group of routers before, you'd realize that if the devices belong to different broadcast domains, you may likely configure a lot of the routing. So if we want to go the simple way, we need to configure many static routes to ensure that the terminals can reach each other, even though the broadcast won't cross the routers. But this is still not a recommended method to deploy and isolate users. So this is what brings us down to the use of the VLANs. So basically, a VLAN is the meaning of the VLAN is a virtual local area network. It is a layer 2 technology that allows a large broadcast domain to be split into smaller broadcast domains. I mean, this technology can even be applied to a network as large as this. So if you want the source PC and the destination PC to reside on one broadcast domain, you can easily do this, such that when the source sends a packet, even though all the switches along the path does not recognize the MAC address of the destination, the broadcast will only be limited to this VLAN in this case. So now we're going to use this to describe this concept. The first thing we need to realize is when we talk about the VLANs, there are multiple ways that you can assign devices to different VLANs. Devices are identified in different VLANs based on the VLAN IDs. So VLAN IDs are a group of numbers you can use to identify devices connected to different VLANs. So the VLAN ID ranges from 1 to 4094, with 1 being the default VLAN on the network. So when you have a couple of devices set up, a couple of switches, they're going to run the VLAN 1 by default. So one thing you want to do is to change these VLANs. For example, we want all the odd numbered PCs in this case to reside on VLAN 10, and the even numbered PCs to reside on VLAN 20. So what that guarantees is, even though they're connected to the same switch physically, only PC1 and PC3 can communicate with each other. PC2 will never communicate with PC1 and PC3 as long as the communication takes place at the data link layer, at the layer 2. So the two things we need to realize, one is the VLANs can split the large broadcast domain into smaller broadcast domains, and each broadcast domain in a VLAN topology can be identified by the VLAN ID. And then how can these devices be actually added to the VLAN? So to include a device to any VLAN, we have several methods by which that could be done. The first one is port-based VLAN classification. This is the most widely used classification on enterprise networks, and it uses different types of interfaces such as the trunk interface, access interface, and hybrid interface. Like we have in this scenario, we have the access and the trunk link. And then VLANs can also be assigned based on the MAC address of the terminals, the protocols used, the subnet, and policy-based, which could be a combination of two or more of the previous methods. So we're going to be demonstrating the port-based configuration method in this scenario. So to understand this, we need to know that the VLANs are supported on the switches, but not by the PCs. The PCs only need to send the traffic. They're unaware of what VLAN they reside on. So because these PCs are not aware of the VLANs they reside on, we say that they're VLAN unaware devices. So basically, all the frames or packets sent by these devices do not come with any VLAN tags by default. So when you have a connection between a VLAN unaware device on a switch, we call the link that connects them to be an access link, because this is where the end stations gain the access to their VLANs on the switch. And the same thing applies to this one as well. So for all the links connecting the VLAN unaware devices to the switch, they are access links. And then for two VLAN unaware devices on different switches to communicate, then the link connecting the two switches need to permit that VLAN. For example, PC1 can communicate with PC10 directly, because when the traffic is sent, it's going to be tagged on the switch with the VLAN ID configured on the port of the switch, right? So in this case, if PC10 sends a frame, for example, headed for PC5, then the switch 1 needs to be able to permit traffic from VLAN 10 in order for switch 2 to receive this VLAN frame and also forward to PC5. So let's go ahead and do some configurations on this one. So before we begin, let's go ahead and start the devices. Right, so this is just gonna take a few seconds, but before that, let's check. Okay, the devices are started now, and so let's go ahead and check the IP address configured on the devices. For PC1, the IP address is 10.10.10.1. This is basically the same subnet range on all the devices. However, PC1 is having a host IP of host ID of 1, and then the PC2, for example, .2, that way to PC6, which is .6. So let's go ahead to do something first. PC1 can directly ping PC5. So from PC1, we're going to ping 10.10.10.5 PC5. And then we can ping PC5, right? And then let's go ahead and ping PC6. Right, we can also ping PC6. So PC1 can ping all the PCs as of now because we don't have any VLAN configurations. What we want to achieve is an isolation between devices on this network. So we're going to place all the odd numbered PCs on VLAN 10 and the even numbered PCs on VLAN 20. So let's start by configuring the switch 1. So what we're going to do is, first of all, we're going to use the port-based VLAN configuration method. So all the interfaces, like we have gig 001, gigabit Ethernet 001 connected to PC 1, and then we have gigabit Ethernet 002 and gigabit Ethernet 003. So we can go ahead and turn on the show all interface, so it will be much easier for us to do. So now we're going to change first the system name by going to the system view first, and then we change the system name to switch 1, right? And then we open switch 2 as well and do the same thing. So system view, system name, switch 2. Good. So that's the first thing we're going to do. Now the next thing we want to do is to enable the VLANs that we want on the devices. So the first thing is, for switch 1, this is the command to activate the VLANs. So VLAN batch, that's the command. So the two VLANs we want on this switch are VLAN 10 and VLAN 20, right? So now we have done the configuration. We do a similar thing on switch 2. So let's go ahead, let's move this up a bit so we can see the description exactly. Now we do the same thing, VLAN batch 10 and 20. So listen, just Okay, so you need to pay attention to this. When you enter the VLAN batch command, you can specify the VLANs as distinct values, or you can specify as a range. So if you want to specify a range, for example, from VLAN 10 to VLAN 20, you use the words, you use the command 10 to 20. But if you want to only configure VLAN 10 and 20, you just VLAN batch 10, 20. This is how you do it. The next thing we're going to do is we're going to configure the ports connecting to VLAN, to PC1 to VLAN 10. So that port is a gigabit Ethernet 001 on switch 1. So let's go to switch 1 and configure the access port. Now interface gigabit Ethernet 0/0/1. Okay, this should be GI instead. Display this. Right, so let's go ahead and configure this. So the command is, we need to change the port link type first, access, because it's an access link. Now port, okay, give me a moment, right. Port default VLAN 10. That's it. Display this to see. Now we have the link type as access, and we define the VLAN to be 10. So what happens now is when PC1 sends a frame, untagged frame, it gets tagged on port 1 of the switch. And then we do a similar thing for PC2 on port 2. So 002, ports link type access. But in this case, we need to configure the VLAN to be 20. Port default VLAN 20. Display this to confirm the configurations on the interface. Now we do the same for port 3. Port. Now here's something cool. You can actually use just the first letters for each of the commands. Port link type access. Port default VLAN 10. Display this. You see, the same thing. So this is how we're going to configure for switch 2 as well. So let's go ahead. We already enabled the VLANs we want to use on the switch, which are the VLAN 10 and 20. So let's go ahead. Interface gig 004. Port link type access. Port default VLAN 20. Interface gig 005. Port default VLAN 10. Okay, let's port link type access first. Port default VLAN 10. Interface gig 006. Port link type access. Port default VLAN 20. Display this. All right. Now the next thing we want to do is to configure port 10 on switch 1 and switch 2. So this is a trunk link. What we do after specifying the link type as trunk is to permit the tagged VLANs 10 and 20, so that devices that reside on the same VLAN on these two switches can pass the tagged frame across the link. So let's go ahead and do this on switch 1. So for switch 1, we need to go to the interface gig 0010 and then display this. There is no configuration on the interface right now. So we do this, port link type trunk. And then we say port trunk allow pass VLANs 10 and 20. And then we do the same for switch 2, ports link type trunk. No, let's go to interface gig 0010 first. Ports, link type, trunk. Ports, trunk, allow pass, VLAN 10 and 20. So now we're done with the configurations for the access in the trunk port. When we go ahead and ping an odd numbered PC like PC5, we can be able to communicate from PC1 because they reside on the same VLAN. Now let's go ahead and ping PC6. Now there's no communication and the host is unreachable because they reside on different VLANs. Now we have been able to successfully isolate the odd numbered PCs on this network from the even numbered PCs on this network. So if you have any questions or comments regarding this video, you can leave in the comment section, and if you have any suggestions or requests for videos we can make, we'll be more than glad to do that. So please don't forget to hit the subscribe button, and I will see you in the next video. Thank you for watching.